Okay, now into my favorite feature, Hyper-V Replica. This was designed for the SME, the small medium enterprise. It's disaster recovery replication that is completely hardware agnostic. It doesn't care what hardware you're using. So if you ask me, will this work if I want to replicate from EMC to Dell? I'm going to laugh at you because it doesn't care. So don't ask the question. And one of you will ask the question later on, I know it. We'll find out who that is. We'll take a picture of that person and put it up. It was designed for the SME, but Microsoft found out fairly quickly, by accident, that the corporates were very interested in this as well. So what we get from Hyper-V Replica is software-based, asynchronous, change-only, compressed replication that requires no additional licensing. It will replicate quite happily from a non-clustered host to a non-clustered host, a clustered or a host cluster to a host cluster to non-clustered hosts, non-clustered hosts to a host cluster. Again, it doesn't care. We can have Hyper-V clusters up to 64 nodes. We enable a special role called a Hyper-V Replica broker that is highly available on the cluster. That basically means we only have to configure Hyper-V Replica once for the entire cluster. So it's an efficiency thing. We can do it through the GUI. We can do it through PowerShell. In fact, if you do it through PowerShell, it's just a lot easier. And you'll see how easy I have it down to at this point in a little while. It's built in. So there's no expensive SAN replication. SAN replication is expensive. It's not just for the SAN. Maybe you've, depending on the SAN, you've got to buy a special license. And you've got to have oodles of very low latency bandwidth. And we have that floating all about the country right now. Oh no, we don't. This doesn't really care. So you can quite happily replicate from Buenos Aires to Beijing, which is very cool, which is why the corporates started looking at this thinking that's actually interesting. We can start replicating from various branch offices around the world to central locations. And because it's hardware agnostic, we don't care what storage they've bought in the branch offices. We just continue to use centrally what we prefer to use. And we have skills in, so we don't have to match what they buy. Or they don't have to match what we buy. So we can take advantage of whatever pricing is available to us locally, or skills are available to us locally. It's change only. It uses a logging process. So basically, any changes that are being done to our virtual hard disks here are being logged, and every 5 minutes that log is shipped over here and replayed. It's very clever about the process. It compresses. It allows us to turn off that compression if we have accelerator devices like WAN scalers or riverbeds, because they will always do a more efficient, we'll call it a replay process, than compression can ever get. And it's much more efficient. And it's only last write to a block. So if we got continuous change to one block, it's only going to take the last one. It's every 5 minutes that it does this replay. That is not configurable. So the first person who asks if we can change that every 5 minutes, we'll also take their photo and put it up. Usually when I'm on the training course and there's only a few people in the room, I threaten to hit the person who asks. But some of you are big, so I'm not going to do that. And he knows martial arts. So it's a very nice solution. I really like it. And it's built in. It is a wizard away for each virtual machine. So what I'm going to do is actually show it to you. Oh, what I should mention is you can do this quite happily from one site to another within the same Active Directory. Very easy to configure. Or if you're a service provider, you can enable the SSL authentication and communication method and use certificates to provide a service to your customers. So if your customers can't afford a DR site, you can set up a multi-tenant infrastructure, so a single host, a single cluster, and have all your customers replicate their stuff in. And John will show you how to have multiple 192.168.1 networks in the same infrastructure and not really give a damn. They will continue to operate and communicate effectively. So, here I have 3 virtual machines, Replica 1, Replica 2, Replica 3. They're running a very strange operating system, something called Ubuntu. I think it's a new version of DOS. I deliberately choose to use Ubuntu because it has the Linux integration services from Microsoft built into the kernel. I did not have to install anything in Ubuntu to make it work effectively on Hyper-V. So I can right click here and go shut down, and it will cleanly shut down. It syncs its clock and all that good stuff. It supports live migration, Hyper-V Replica, etc. So what I'm going to do is I am going to first enable inbound replication. So I'm going to replicate from host 1 to host 2. And host 2 right now has the default settings, I believe. Replication is not configured. So I'm going to enable replication on this server. Now if I was replicating to a cluster, or even from a cluster, I would enable the Hyper-V Replica broker role in the cluster. You saw me enable scale out file server role yesterday. Similar deals, same wizard. And we would go through the same settings here. So enable this as a replica server. Choose my communication, my authorization protocol. If I had SSL certificates that were mutually trusted, I would import them and I would select that option there. And from then on, any replication will be done using SSL, making it appropriate for untrusted networks like the internet. You may wrap that up in VPN if you feel safer with that. I'm going to go with the simple option, which is the consultant and demo friendly one, which is just use Kerberos, so I don't have to do any certificate stuff. Host 2 will authenticate host 1 using Active Directory. Down here, I have two different options. Where do I want to store the inbound replica virtual machines? Typically what you see in a demo is people checking this one, which is any virtual machines that come in go to this just single folder or single drive or whatever. If you're in a multi-tenancy type thing, or if you're fussy about folders and stuff like I am, you'd actually go with this option down here. And this is where you can say anything that comes from this particular host or cluster, I'm going to store it in this folder. And I'm going to put this label on it here. Now that label is there for you. It's not used by Hyper-V in any way, shape or form. It's kind of like your way of saying these virtual machines here are from customer A, these ones are from customer B or whatever. So in this case, what I have done is I've said any replication coming in from demo host 1 is going to go to this folder here, DHVR customer A, and I've labeled it as customer A. So if I click OK, I now get a warning. Please make sure your firewalls are configured to allow inbound replication. So Windows Firewall, there's two rules. One for Hyper-V Replica on port 80, and one for Hyper-V Replica on port 443, so SSL. But you also have to remember to do that on your physical firewalls. A lot of people will probably forget to do that. So if I go Start, Firewall, that was so much quicker than navigating the control panel, wasn't it? The new UI isn't all that bad. Now you can see I'm lazy, I've turned off my firewall, but I'll show you where the rules are anyway. So I'd right click on that and I would enable it. If I was using port 80, and I would use that, or I would enable that one if I was using 443. And now I'm at the position where I can start configuring replication. We can configure this on a per VM and even a per virtual hard disk basis. So we can be selective about which virtual hard disks we want to replicate to the DR site. So I'm going to do this first one by hand. Enable replication. Type in the name, usually the FQDN if you're doing it across the internet, so the fully qualified domain name. Next, pick what sort of authentication I want to use to do the replication. If I have a certificate, I would use that option there. If I was working with a service provider, the service provider may actually generate that certificate for me. And down here is where the traffic is compressed. It's compressed by default. If I have riverbeds or WAN scalers in the primary and the secondary sites, I would actually clear that box. Next, I have only a single virtual hard disk in this VM, but if this is a Windows VM, we got a very nice tip from Microsoft. Put the paging file in the second virtual hard disk and don't replicate that paging file virtual hard disk. The paging file is constantly trashing. So we'd be constantly replicating over non-persistent data that we really don't need to reboot the VM in the DR site. The VM will quite happily boot up without that virtual hard disk. In fact, we'll create a temporary paging file to get itself up and running. So we can save ourselves a good bit of bandwidth there.
So is that just basically creating a completely separate VHD just for the paging file itself?
Yeah.
So we're not talking, let's say I have a system drive, C drive.
I would create a D drive just for the paging file.
And then maybe an E drive just for the paging file itself.
Yeah.
What sort of a disk I/O hit is there for the logging process?
It's very minor. I don't have the precise details here with me. There was a presentation at TechEd Europe 2012, which you'll find on Channel 9, that goes into great detail on those figures. It's actually very minor in the primary site.
Right.
The IOPS potentially are significant in the secondary site.
Is it a similar process to CVT and VMware?
I can't comment because I don't know it. But it is quite minor in the primary site. Okay, here's a cool feature. Do I want to keep historical copies of the virtual machine in the disaster recovery site? So maybe my disaster actually causes some sort of corruption to my VM, which means the replication would also be, or the replica copy would be protected or corrupted. I can potentially keep historical copies of the VM, so I'm able to travel back in time and fire up that older version of the VM. So what it actually does, if I use this feature, is it creates snapshots using the Hyper-V snapshot feature, or in VMM world we call it checkpoint. And it does that once every hour, and we'll keep up to 15 copies of the VM using those snapshots. Very important change with snapshots in Hyper-V is that when you now delete a snapshot in Windows Server 2012 or Windows 8 Hyper-V, it merges the AVHD or AVHDX right there, right then. You do not have to shut down the VM to get the snapshot to disappear. That's a major improvement and has probably prevented a lot of support calls from Microsoft. If we want, we can actually say we want these snapshots to be generated using VSS. So if we want to absolutely guarantee application consistency, we can do that. However, Microsoft are finding in their testing that they don't really need to do that. At least the Hyper-V guys have been finding that they don't need to do that. Okay, this is where you typically get the big question. How does my data get across to the secondary site? Well, the default option is to send it over the network. So if you've got oodles of bandwidth, you can replicate this VM over the bandwidth to the secondary site as soon as you finish the wizard. If you're in the SME world and you do not have oodles of bandwidth, you can choose some of the other options. Maybe I do it over the network, but I wait until Friday, 5 p.m. And then it will continue to replicate do the initial copy until it's done. There's no windows or anything, it will just do it until it's done. Not necessarily ideal either. This one here is where we actually have a backup of the virtual machine, and we have that backup in the secondary site, and we restore it. And that's the initial seed. It'll do a synchronization to fix up the differences since that backup, so you use the most recent backup you can. And then it will start the replication process. So that's handy if you've got offsite backups already in the DR site. And this one might be useful for the service providers. Send the initial copy using external media. Plug in some sort of drive or use a NAS or something, enable BitLocker to go to encrypt that drive so it doesn't get lost during transit and you have an interesting conversation with the Data Protection Commissioner. And when you finish the wizard, it'll basically export a copy of the virtual machine to that removable storage. You take that removable storage to the DR site, a stub of the virtual machine is waiting there, and you right click and you can import the virtual machine's data from that copy. And then it'll do a synchronization over the wire to fix up the differences since you did the export, and then it'll start the replication process. I'm just going to go with the network because I have nice networking, and finish. Imagine doing that for 20, 30, 40, 100 virtual machines. I wouldn't like that. So what I would do instead is I would document what I want. And I've actually done that using a CSV file, comma separated values file. I've listed my virtual machines, where I want to replicate them to, what protocol I want to use to do it, what port I want to do it on, how many historical copies I want to do it, and if I'm doing historical copies, how do I want to use the VSS feature? And I can add more features in there if I want as well. And then I'm going to read that file in using a PowerShell script. File, enable Hyper-V Replica. And this is my script. I'm not going to share the script with you. It is in a certain book, I know. It's available in all good bookstores and a few bad ones too. And fingers crossed, if I run that, that is now reading in that CSV file and configuring replication for those virtual machines. And then I could put it, I have a delay timer in there to basically let one go at a time. And then that document is there as part of my business continuity plan, that formal document that I use for all my DR planning and invocation and quality control and all that sort of thing. I could actually put in extra values in there as well for actually orchestrating the failover of my virtual machines, and then read in that file again and run it with a different script. Funny enough, I have a script just like that, but I'll show you in a while. So at that point, ooh, I scheduled my replication. Silly, silly boy. Replication, remove replication. Replica 1, replication, remove replication. Silly, silly boy. That's what I get for not paying attention while I'm demoing. So enable replication, demo host 2, next, 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 finish. So even if I'm doing it by hand, if I'm doing it over the network, it's pretty simple and pretty quick. So once that one is replicated, I'm actually going to have a disaster. So it's not that different to the demo Dave showed you yesterday. Actually, no, Dave showed you the unplanned failover yesterday. What I'm going to do is the planned failover. The one that actually saved some businesses in New York State when Hurricane Sandy came along. Because we all kind of knew this thing was coming. They had like 5 days notice that there were bad floods coming to the East Coast region. So what they did was they right-clicked. Actually, no, before they even would have done that, what they would have done is gone Settings, Network Adapter, Failover TCP IP. If I wasn't doing the network virtualization thing, I could actually put alternative IP configurations from my VM in here. And for test failover, I could actually configure a specific virtual switch to isolate any test copies of this virtual machine that I would fire up to test my disaster recovery or my business continuity plan. A business continuity plan that's never tested doesn't exist because people just don't know it and they'll panic like crazy when the real thing comes. Trust me, I've never had a real DR. I've done DR testing and they tend not to go well, at least in the past when I was doing physical servers. What I can do here is I can do replication, test failover. And what that will do is ask me which of my historical copies, if I have any, I want to actually test with. Click test failover. And what it'll do is it creates a copy of my virtual machine, which allows me to power it up and start working away. Now what that copy is it's a copy of the virtual machine configuration with a differential virtual hard disk that basically only stores the differences from the original one. So it'll boot from the original one and only save any changes to the differential disk. So the replica there is actually still there, replicating away, just in case a real disaster comes along. And I don't have to re-replicate the replica. And when I'm all done, I can right-click, replication, stop test failover, and it cleans up the test. So that's a test failover. Now let's do the Hurricane Sandy thing. We watch CNN and Fox News and they tell us it's a red alert or an orange alert or whatever, and I am going to shut down that virtual machine, and then I'm going to right-click, replication, planned failover. And if I hit that failover button right there, which I'm not going to do at the moment, what it will actually do is it will push out the last bit of replication traffic, and power up the virtual machine in the secondary site, and automatically reverse replication to the primary site, just in case the disaster doesn't hit. Because then I can do another planned failover in the secondary site to get my VMs back in the primary site. Now what I am going to do is I'm going to create a real disaster. I've had a fire. Turn off. Oh no, I've had a fire. My business is gone. No, it's not. I've got my VMs in the secondary site. Yay, I'm saved. Get some laptops or whatever, and I'll be able to connect into these, call someone up, whoever's running this infrastructure. Maybe it's a service provider, hosting company, a value-added reseller, whatever. And I can say, please get me up and running. How long is it going to take? How long will it take for your VMs to boot? Quicker than physical servers would. So I can just go right-click, replication, failover. But what I'm going to do is just better again. I'm going to orchestrate my failover. Who needs System Center? I've got PowerShell. File and unplanned failover. And what it's going to do is it's going to read in that comma separated values file. And it's going to say on this particular host, fire up this virtual machine first and give it 60 seconds to start up. And if it doesn't start up in that time, log a failure. So it's actually going to write stuff out to a log file so I can analyze the results. It's also going to be spitting out information on screen so I can monitor this. And that is now orchestrating my virtual machine failovers. So first one is booting. And now it's actually, what it's doing is reaching into the integration components to see if the heartbeat comes online. Basically, is the operating system running? And as soon as that heartbeat comes up, Replica 1 is running. And it moves on to Replica 2. So it doesn't wait the full 60 seconds. It's only waited 30 seconds approximately there. So that, how long has it taken me to fire up 100 VMs with that? Not very long. When I worked in the banking sector, in our head office, we were actually allowing 4 hours for invocation of our DR plan. If I had this, I'd probably have gotten our 100 or so servers up and running in 4 minutes, let alone 4 hours. This is just super cool. And then if I combine remote desktop services, instead of deploying at physical desktops, and use remote desktop services to fire up virtual machines so I can actually access these services. It's one thing to have the services up and running, but if nobody can get to them, they're pretty pointless. So service provider world, maybe use RDS and just give your customers a portal and say, go to that portal, click the thing where there's a session host or a desktop or whatever, and you're in. Go to Harvey Norman's or wherever, buy a bunch of laptops, go to a hotel, use our wee free Wi-Fi and drink coffee all day so you can justify sitting in their lobby. I think about these things. If you're operating on a budget, you're operating on a budget. So that's Hyper-V Replica. I think it's a fantastic feature. However, there's more to the orchestration of failover. I've done a very basic, very free orchestration there. It's nice and simple. If you want something a bit more powerful, you can use System Center Orchestrator. And you can create a runbook that does all sorts of clever things like reaching in and finding out not only is the thing heart beating, but has SQL started, has Exchange started, whatever. Actually find out how things are behaving. Use Operations Manager to detect if end users are actually able to access the service. And of course, there's a new product. Those of us in the Republic cannot access the preview yet. I think they're just targeting me. But if you're from Northern Ireland, you can play with this preview. It's called Hyper-V Recovery Manager. And this integrates with Virtual Machine Manager. So the thing that creates your clouds and gives you centralized management and all that good stuff. A Hyper-V Recovery Manager runs in Azure, so in Microsoft's data centers. And on there, you can actually configure and manage your replication and create your runbook for failing over your virtual machines, whether it be planned or unplanned. So that's going to be a very nice tool when we finally get our hands on it. But if you are in that smaller world, a PowerShell solution will work out nicely. And if you've only got a handful of VMs, doing it by hand is no big deal anyway. Because right-click, failover, doesn't take very much work. when you get into 100 VMs or whatever, you really want to start looking, orchestration. Or if you're a service provider and you've got lots of customers and you need to know specific orders of each of those customers, then the orchestration makes sense.